In this video, I'll provide you with an introduction to virtualization where we'll learn many of the basic concepts of what a virtual machine is, what a hypervisor is, and how we can provide resources to our virtual machines that are actually the shared physical resources of an ESXi host. So what is a virtual machine? Well, it's very similar to a physical server. You have an operating system, and the operating system has no idea that it's going to be running on a virtual machine. So if I have Windows or Linux running on my VM, that operating system is called the guest operating system, and it has no awareness that it's running as a VM. Now, a virtual machine does not have its own dedicated hardware, but like I said, the guest operating system doesn't know that. So a virtual machine will run on a physical server with many other virtual machines. Right? They'll share the physical resources of the host. And this is the first big benefit of virtualization. We can run many machines on shared hardware, each with their own independent guest operating system. And those virtual machines can share a common set of physical resources like CPU, memory, network, storage. So unlike a physical server, the virtual machine does not truly have its own dedicated physical hardware. It's using the shared hardware of an ESXi host. And that's what the ESXi host is. This is the actual physical server that our virtual machines will run on. So the virtual machine is almost like a program running on a computer. We have different programs that consume different amounts of resources. And we have different VMs running on the same physical host. And some VMs may consume more CPUs, some may consume less. Some might consume more memory or produce more storage traffic. Other virtual machines, less. So the ESXi host is like our physical server, and ESXi is the operating system that we install on that physical server. And ESXi is what we refer to as a type 1 hypervisor. That means it runs right on the hardware. It doesn't require any other operating system. So if you're familiar with VMware Workstation, that's a hypervisor that runs on top of Windows. There's no underlying operating system on the ESXi host. It's purely ESXi running on physical hardware. And then the virtual machines run on top of ESXi and can utilize the physical resources of that host. So again, here we see many virtual machines running on the same ESXi host, again utilizing the shared physical resources provided by that host. Now our ESXi host is an example of a type 1 hypervisor. And a hypervisor adds what we call a layer of abstraction. So there's a layer of abstraction between the virtual machines and the physical resources. Now, what does this layer of abstraction mean? Well, let's take a moment to think about this. So let's say, for example, I'm sitting on the couch and I have myself a bowl of M&Ms. And I see my son coming towards the living room. And I take a napkin and I cover up that bowl of M&Ms. I've just created myself a layer of abstraction. Right? I've hidden those underlying physical resources from the people who want to consume those resources, my son. And that's kind of like what a layer of abstraction does on the ESXi host. It creates this layer between the virtual machines and the physical hardware. And it gives us this management capability where we can intelligently divide up those resources. So for example, as a virtual machine is trying to access physical memory, it's going to access that memory through this hypervisor layer of abstraction. And now we can intelligently decide, well, the first VM might be able to access 4 gigs of memory, and the second VM might be able to access 2 gigs of memory. And maybe the third VM will take precedence over the other 2 VMs. And we can establish all of these controls because of this hypervisor layer that rides in between the virtual machine and the physical resources. So my VMs are not actually seeing the physical resources at all. They're seeing a virtualized version of those physical resources that we can control because of this layer of abstraction that exists. And one of the most important resources that's shared across virtual machines are my CPUs. So in this slide, we see an ESXi host. And this ESXi host has 4 physical CPUs. Right? Let's assume that those are 4 processor cores on the same socket. Right? So we've got a situation in which we've got 4 processor cores, and we've got a lot of virtual machines here. Right? Here you can see we've got 12 virtual machines displayed. Right? So we've got these 12 virtual machines that are sharing 4 physical processor cores. This is called oversubscription. We may only need 4 processor cores to meet the requirements of 12 virtual machines, because odds are all of my VMs are not going to be consuming as much CPU as they possibly can at all times. That's what the concept of oversubscription is all about, and that's how we efficiently utilize the resources of our ESXi host. Think about it this way. Let's say that we have a restaurant, and we know that we're going to have a certain number of people that visit our restaurant every day. So maybe, for example, we'll know that we'll have 200 people who are going to come to our restaurant every day. Well, I may just simply build enough tables in this restaurant to seat 50 people at any given moment. So I'll build my restaurant for my normal usage. Right? I might have 200 people per day, but odds are I'm not going to have all of those people at the exact same moment. Some will come for lunch, some will come for breakfast, some for dinner. And so it would really be wasteful of me to size my restaurant big enough to seat 200 people, because I'm probably not going to have that many people at once. The same concept applies to virtualization. I'm not going to size my physical CPU resources for my worst case scenario. Now, there may be times where all 12 of these virtual machines have a CPU intensive running task, right? And that's just like 200 people showing up to my restaurant at once. If all 12 of these VMs are carrying out some sort of CPU intensive task, they're going to be waiting. There's going to be slowness. Just like the restaurant example of 200 people showing up at once, there's too many people and not enough physical resources, not enough tables available. So it's always a balancing act when you're creating your ESXi hosts, because you don't want to purchase a bunch of unnecessary physical hardware, but on the other hand, you don't want bad performance. So we always have to find that sort of fine line. So as we go ahead and create our virtual machines, we can size them individually. Right? So we could say maybe one VM will get 4 virtual CPUs, and one VM will get 2 virtual CPUs, and one VM will get 1 virtual CPU. And all that does is govern how many processor cores each VM is allowed to take advantage of. So our hypervisor layer, or our layer of abstraction, gives us the ability to have a shared set of physical CPUs that are used by a group of virtual machines. And memory virtualization is a very similar concept. I'll probably have virtual machines running on an ESXi host that exceed the amount of memory that that host can actually deliver. So maybe if I add up all of my VMs over here, the total memory that I'll allocate to them will be 48 gigabytes. But maybe in my host, I'll actually have 24 gigabytes. I'll oversubscribe just like we talked about with CPU. And as these virtual machines need to utilize memory, as they actually require those memory pages will be mapped back to physical memory on the ESXi host that's shared by all of my virtual machines. Right. So I kind of call it the 4 food groups, right? The ESXi host provides CPU, provides memory, and it also provides network virtualization and storage virtualization. And the network virtualization part of our picture looks a little bit different than the other resources that we've already looked at. Okay, so from a network virtualization perspective, we now have this component here called a vSphere standard switch. This is a virtual switch. And like I said, my VMs work pretty similarly to the way that a physical server works. So when I create a virtual machine, I need to plug it into a network. Just as if I was putting a physical computer on the network, I have to do the same thing with a VM, right? I have to plug it into a network. And we'll take a little bit closer of a look at that later in this course, but essentially what I'm going to do is I'm going to establish a virtual connection from this VM to a port on a vSphere standard switch. And by the way, my VMs that are running on this host, they can all communicate via that vSphere standard switch. They can talk to each other. They can communicate without their traffic ever even leaving the ESXi host. But if there's something out there that they need to communicate with, like a physical server, they can do that through a vSphere standard switch, and they'll have a connection to a physical network and be able to talk to devices that are outside of that ESXi host. So that's the purpose of the vSphere standard switch and of network virtualization, is to provide network connectivity to our virtual machines. And storage virtualization is very similar. Right? My virtual machine is going to have virtual disks. Remember, I've got a guest operating system running in each of these virtual machines, like Windows or Linux. Both of those guest operating systems need to be able to access their C drive, right? Their files that make up that VM. And so as the virtual machine generates storage activity, that storage activity in the form of SCSI commands is captured by the hypervisor and redirected to the appropriate storage location. And that's the other purpose of the hypervisor, is to provide access to a variety of different methods of storage. We'll talk about those later on in this course, like virtual SAN, VMFS, NFS, virtual volumes. But at this point, what we really want to understand in this first lesson is simply the fact that I have multiple virtual machines running on a physical ESXi host, and the physical ESXi host provides access to our 4 food groups: CPU, memory, network, storage. Now, one more thing about our virtual machines that's important to understand at this point. A virtual machine is made up of 2 major pieces. Right? We have the virtual machine files and the live state of the virtual machine. So let's talk about the live state first. Right? Every virtual machine that's running is going to have contents in memory. Right? This is all the programs that are running in the current state of the virtual machine. The virtual machine is going to be using time slots on processors. It's going to have a virtual NIC that's connected to a port on a virtual switch. And it's going to send SCSI commands that are intercepted by the ESXi host and passed along to a storage adapter. So this is what's happening in my virtual machine right now, at this given moment, the virtual hardware that we're providing it, and the contents of memory at any given moment. That's what's running on the ESXi host. But the virtual machine is also made up of a set of files, right? Some of these files include our VMDK file, right? The virtual disk of our virtual machine, the VMX file, our configuration file. And those files are located on a data store. And a data store is simply any storage technology that has been prepared to house virtual machine files. Right? When I shut down my VM, there's no more contents of memory. The virtual machine's not being scheduled on a processor. Right? It's not generating any network or storage traffic. Right? When I shut down my VM, it's still registered to a host. Right? We still know which host it's going to run on next time we power it up. But basically, when a VM's powered on, all that really remains is the set of files that we're going to use to boot that virtual machine up next time. So our virtual machines are made up of the live state. Right? That's the part that's running on the ESXi host. That's the contents of memory, the virtual hardware. And they're also made up of a set of files located on a data store. So that's what our virtual machines are, and this is basically the building block of the software-defined data center. Right? So when we start taking physical servers and virtualizing them, creating many VMs running on multiple ESXi hosts, and doing things like having virtualized networks, having storage arrays that our virtual machines utilize for storage, and things like that, we've gone to a software-defined data center. Right? And if I want to, I can create multiple virtual data centers in the same building. I can create a virtual data center that spans multiple physical locations. I have all kinds of options. And that's the biggest difference between a physical data center and a software-defined data center, is the fact that a software-defined data center is not defined by four walls and an air conditioning unit and power, right? Like our physical data center is. A software-defined data center can span physical locations. We can make it bigger. We can make it smaller. It's scalable and dynamic. Finally, one last term I want to talk about. What is the cloud? Well, we're going to keep this very simple. So a private cloud is essentially a virtualized environment. Right? I've got a bunch of ESXi hosts. I've got virtual machines running on it. And that's my own little private cloud. My own equipment. And there's no kind of third-party hosting service or anything like that. Now, if I decide to, I can also utilize the public cloud. And I like to think of the public cloud as like a utility company, right? So if you're building a new house, you can just call the power company and get your power turned on, right? You don't have to put generators in your basement or solar all over the roof. You can just call the power company and get power. Right? That's kind of like the public cloud. You can just simply utilize their existing physical infrastructure. They have the servers, they have the storage capacity, the network capacity to run virtual machines. And that's what a public cloud provider is. It's sort of a utility provider for compute and storage capacity. AWS is definitely the most well-known example. And I also teach AWS classes as well. I teach a lot of live AWS classes. And AWS and VMware are definitely getting more closely integrated as time goes on. So if you're ever curious about any of that stuff, or you ever want to take a live class, feel free to reach out to me on LinkedIn, and I'll be glad to help you out. But yeah, that's what the cloud is, right? So public cloud, think AWS, think Google, think whoever, a public cloud provider. That's their physical hardware, their compute and storage, right? And then you can also do something called a hybrid cloud, where you have some stuff running in a private cloud and some stuff running in the public cloud. All right, so let's review. A virtual machine has a guest operating system. It has virtual hardware. It doesn't actually have any physical hardware that's truly dedicated to it. And many virtual machines can run on a single hypervisor. Right? ESXi is a type 1 hypervisor. And that's our physical server. And the resources of that ESXi host are shared across multiple virtual machines, and they're presented to virtual machines using what we call a layer of abstraction. We can have multiple virtual data centers in the same building. We can have virtual data centers that span multiple physical locations. And we also briefly introduced what a cloud service provider is, with the most common example being